If mitochondria are the engines of our cells, then sirtuins are the maintenance crew, silently cleaning up, tuning genetic machinery, and making sure our cellular parts don't rattle themselves into a midlife crisis. These guardian proteins don't just extend yeast lifespan for fun. In mammals, they regulate inflammation, DNA repair, energy metabolism, and even whether a cell takes a graceful bow or a dramatic exit into apoptosis. But here's the catch. Sirtuins are highly dependent on NAD, and NAD levels drop like your motivation at 3 p.m. on a Monday as we age. Fortunately, dietary choices, especially those involving resveratrol, niacin, and fasting, have been shown to wake up this sleepy longevity machinery. Welcome to the curious and promising world of sirtuin-activating compounds, STACs, where gene expression meets dinner plans. Let's start with sirtuins themselves. There are 7 in humans, SIRT1 through SIRT7, and they each have their own favorite hangouts, some in the nucleus, others in the mitochondria, and one especially fond of the nucleolus, which is either poetic or territorial. We're not sure. These proteins act as NAD, dependent deacetylases, which is a fancy way of saying they remove acetyl groups from other proteins, changing how genes are expressed, enzymes function, and cells respond to stress. Sirtuins help activate antioxidant defenses, inhibit inflammatory pathways like NF-B, and promote autophagy, the spring cleaning process that prevents cellular hoarding. And their most famous trick? Delaying cellular senescence, the biochemical equivalent of telling your cells, don't retire just yet. So how do we keep these sirtuins from slacking off? One way is by boosting NAD availability, and this is where niacin and its family of precursors, nicotinamide riboside NR and nicotinamide mononucleotide NMN, enter the chat. These compounds act as raw material for NAD synthesis, and increasing their intake has been shown to elevate NAD levels in tissues, which in turn fuels sirtuin activity. It's like giving the maintenance crew extra tools and better lighting. Clinical trials have shown that NR and NMN supplementation can improve markers of metabolic health, reduce oxidative stress, and potentially slow aspects of biological aging, although the live longer evidence in humans is still more of a hopeful wink than a mic drop. Still, when it comes to cellular energy, mitochondrial health, and gene regulation, these NAD boosters have serious potential and very few side effects, unless you overdo it and start generating the aforementioned inflammatory metabolites, looking at you for PY and 2PY. Then there's the rock star of sirtuin activators, resveratrol, the polyphenol most famously found in red wine. Resveratrol directly activates SGRT1 and maybe others, mimicking the effects of caloric restriction without having to give up dinner. It stimulates mitochondrial biogenesis, improves insulin sensitivity, and flips on genes that help cells adapt to stress. In rodent studies, resveratrol extends lifespan, particularly in metabolically compromised animals, and improves cardiovascular function. In humans, the results are more modest but still promising: improved endothelial function, reduced inflammation, and better glucose control. It's no immortality elixir, but it might help your cells act a few years younger, especially when combined with other NAD-boosting strategies. But perhaps the most primal and effective way to activate sirtuins is fasting. Whether it's intermittent fasting, time-restricted eating, or alternate-day fasting, calorie restriction naturally raises NAD levels, lowers insulin, and triggers sirtuin activity across multiple tissues. Fasting also reduces mTOR signaling and increases AMPK activation, creating a metabolic environment that favors repair over growth. The body essentially says, times are tight, let's tidy up and make do with what we have, and sirtuins are the supervisors of that internal reorganization. Interestingly, some research suggests that fasting and polyphenol intake work synergistically. Fast to raise NAD, then eat resveratrol-rich foods to put that NAD to work. It's like setting up the chessboard during your fast and then making brilliant moves at your next meal. Of course, this wouldn't be a proper longevity discussion without a cautionary tale. Activating sirtuins willy-nilly isn't always a good idea. In some cancers, overactive sirtuins may help rogue cells survive longer than they should. And hammering the NAD system without understanding your body's methylation status or clearance pathways could lead to buildup of undesirable metabolites. More is not always better. It's about balance, timing, and individual context. Personalized nutrition, Genetics and biomarkers should ideally guide whether someone should fast more, sip more resveratrol, or start taking NR before breakfast. Still, the general themes are clear. Sirtuins like stress, but the good kind. They thrive on nutrient scarcity, plant-based hormetic compounds, and just enough metabolic friction to stay alert. Modern diets full of refined sugars, sedentary routines, and 24/7 snacking? Those are the Sirtuin sedatives. If we want these longevity proteins to keep doing their genetic janitorial work, we need to give them a reason to show up. So whether you're sipping Pinot Noir in moderation, skipping breakfast on purpose, or feeding your NAD, with a little niacin boost, you're participating in a molecular negotiation with your own biology. The Sirtuins are listening. And if they like what they hear, they just might help you live not just longer but better.